Hey folks, welcome to my channel Number Pen. So we have the problem on our screen. Find the derivatives from the left and from the right at x equals 1 if they exist of the following functions are the functions differentiable at x equals 1. The function that have been given is root of 1 minus x square, right? So in this case, what we notice is that the function does not undergo any form of transformation as we move through x equals 1, right? So the function remains the same as root of 1 minus x square, right? So let's write the left hand and the right hand derivative, and again drawing your attention to what we have on the right of the screen, where we have the conditions for differentiability as a function is differentiable at x equals x naught only if f dash of x naught plus and f dash of x naught minus both exist, and f dash of x naught plus equals f dash of x naught minus, right? And let's write our RHD, which is our f dash of x naught plus, right? So this is what we have. My f dash of x naught plus is limit h tending to 0 f of x naught plus h minus f of x naught divided by h, right? So my x naught is 1. I can do a substitution of x naught equals 1 wherever I have my x naught, and then my, right? So this is what I have. Let me move to the next line. What is my f of 1 plus h, right? My f of 1 plus h is nothing but a substitution of x by 1 plus h, right? And what is that? My f of 1 plus h becomes a root of 1 minus, and instead of x square I have 1 plus h the whole square, right? And what is my f of 1? My f of 1 is nothing but f of 1 is nothing but root of 1 minus 1, which is nothing but a 0, right? So I can comfortably ignore my f of 1 because it is a 0, and I can rewrite this as 1 minus 1 plus h the whole square root of that divided by h, right? So this is what I have in my RHD. I think I can further expand my RHD, right? What is my 1 plus h the whole square? It is 1 minus 1 plus h the whole square is 1 plus h square plus 2h, right? So let me write that out. Square plus 2h, right? That divided by h, right? I know that within the square root my 1 and 1 will get cancelled. So I think I can rewrite this particular line, this particular expression in the next line. I remove my 1 from the numerator. I'm left with, remember the minus here folks, that's very important, minus of h square plus 2h. I still have my h in the denominator, which means I'm left with square root of minus of h square plus 2h divided by h, right? I can move my h square into the square root, and we have done this in some of the videos where we solved problems under limits. So I can comfortably move my h inside the square root and rewrite this particular equation as minus of h square plus 2h divided by h square, right? All that I've done is I've moved h into the square root because h is nothing but square root of h square, right? So this is what I get, and I can further represent this as minus of 1 plus 2 by h, right? Because one h will get cancelled out. This is what I have, and I don't think we can further simplify this. When I do a substitution of this as h equals 0, what do I get? It looks like I'm getting a weird number, right? And what is that weird number? I end up getting a square root of minus of 1 plus infinity, right? And what is that? That is non existent, right? Why is it non existent? First, we are tending not towards the finite number, we are tending towards an infinite value. Second is square root of a negative number. Square root of 1 plus infinity into minus 1 is what we have. So, which means we have our RHD does not exist, right? So, we can comfortably write our RHD does not exist, right? Now, we know that if the RHD does not exist, irrespective of whatever is your left hand derivative, we can comfortably say that the function is not differentiable at x equals 1. But still, we've been asked to find the LHD as well in this particular problem. So let's write it down and let's see what do we get. So this is my LHD. My LHD is f dashed of x naught minus, and that is equals f h tending to 0, f of x naught minus h minus f of x naught divided by minus h, right? And like we did in our previous problem, like we did in our RHD, we can comfortably replace x naught as 1. And what is my f of 1 minus h, right? My f of 1 minus h is again, go ahead and substitute my x with a 1 minus h, right? So what do I get? When I do the substitution, I get my 1 minus h the whole square, right? So I have my 1 minus h the whole square. So this is what I get when I do a substitution of x with 1 minus h, right? And my f of 1 is a 0, like we saw in our previous calculation of RHD. And I have my denominator still has got a minus h, right? So I'll retain my minus in the denominator for the time being. And then I can further substitute, then I can further simplify and rewrite the expression inside the square root, right? And what is that? 1 minus h the whole square is 1 plus h square minus of 2h, right? Minus of 2h. And I'll probably, remove the negative sign from the denominator, and my negative sign is, let me put it on the left. Also, I'm going to do a cancellation of 1 and 1 in the next step. And what do I have? I have my expression further simplified. Looks very similar to what I did earlier, but let's see what do we get. I have a minus sign, remember that, and then I have my h square minus 2h, right? And then I have my h in the bottom, and I have a minus sign here as well, right? So let me rewrite this like we did in our previous problem. I can comfortably take my h inside. I still have my minus sign outside, and I have my h inside now, right? So I will be left with a minus of h square minus 2h divided by h square, right? So that leaves me with limit h tending to 0 square root of minus h square minus 2h divided by h square, right? And I can rewrite this as minus of 1 minus 2 by h, right? I have my minus here, and so I have square root of minus of 1 plus 2 by h, right? And what is that? Let us rewrite this. So this is how I write this expression, and I have a minus sign outside. I don't think we can further simplify this. I have a minus of square root of 2 by h minus 1, which is nothing but, again, tending to, this time we don't have a negative number inside our square root, but still it is not a finite number. It is tending to infinity. And remember, we have our negative sign outside of the square root, which means we are tending towards minus of infinity, right? Is equal to minus of infinity, right? So therefore, we saw that our RHT did not exist because we were tending to square root of minus 1 plus infinity, which is again infinite, and it is not possible to have a square root of a negative number, and therefore we can comfortably say our RHT does not exist. And in our LHD, we have that our LHD is tending towards minus infinity, right? So in both the cases, they don't exist, right? So we can comfortably say that LHD also does not exist, right? So it means that the function f of x equals root of 1 minus 1 root of 1 minus x square does not exist because my LHT not equal to RHT, but before that my LHT and RHT, and they do not exist, and function f of x is therefore not differentiable at x equals 1, right? So that's how we go about solving this particular problem. So though we know and we can conclude that, at the end of RHT itself, that this function is not differentiable because RHT does not exist, and we know that the condition for differentiability is both of them will have to exist, but still we've been asked to find both the LHT and the RHT, and therefore we went ahead and calculated the LHT as well. And it is very evident that the LHT also does not exist, and therefore the function is not differentiable at x equal to 1. So I hope you found this content useful. Please do subscribe to my channel and support. Thank you.